It's lab. All right. So let's go ahead and get started on this lab. So this lab will continue your review of arrays in C++, but now as a class. So implement the following class. Wow, that's hopefully straightforward instructions, right? I give you the class right off. I've actually, for this assignment, been even nicer in that if I go into source, int_array.hpp, oh, it's already there. You're welcome.
Thank you so much. I appreciate that. I appreciate it.
So we need to come up, fill out the private contents. We're going to do that in class momentarily. But notice it's an integer array that can take on a standard array with the size. And your directions are copy the array contents into an internal array, do a deep copy. What does that mean? Copy everything. Copy everything. Perfect. Get the link, return the link of the array. Index of value, return the index in the array where the value is found. So it's going to search for the value and return the index of that value. -1, it's not there. Remove at index by shifting everything lower. All right, and then now down here is where things are going to start to heat up a little. Find intersection. You're being passed another integer array. Returns an array of all integers that are in common with self and array. Self is returned, means the current class that's executing, or this, and the array passed in. So you need to create an array. Of course, return an empty array if there's no intersection. So first off, create an integer array. Create it on the heap because you're returning a pointer to a class. Then you need to find all the intersections. And once you find them, make sure you fill out that array and then return it. Okay. No questions? All right. Fun. Oh, it's good. It's good. Good pointer.
So I take it for the like the int get length, you can't just say dot length, you know, how we did in Java.
Oh, that would be nice.
That would be nice.
It would be. But do arrays store anything besides their elements in C++?
No. Performance.
Come on.
Yeah.
But dot length, please. Oh.
All right. This subsequence return true if the array is contained sequentially in self. AKA, is the array here a subsequence of the array you are representing? And then make sure you deallocate with your destructor. All right. Let's go ahead and start coding this. At least some of it, right?
Yeah. Sure.
Did you push any like code outputs already?
Nope.
Okay, just making sure. I did try.
I'd rather you put it up half completed.
All right, integer array. What should we store in this integer array?
An integer array.
Stuff.
An integer stuff. Okay.
An
Stuff.
array of size.
An array of inside. But we don't know the size yet. So we can't store an array. We're storing a. Good. What type is the pointer? An int. What do you want to call it? We'll call it array. Perfect. Anything else we want to store in this class about the array?
The size.
Oh yeah, I bet you'd love to store the size, wouldn't you?
Yeah.
Pretty important. Need that. Yeah, nice.
Can y'all think of anything else? Not really?
You're making this two-dimensional?
No, it's a 1D array.
Yeah, I guess.
Can't think of anything? That's probably all you need. It's good to, the reason why I ask anything else is good for you to pause, think about it for a little while, and if for a minute or two you can't think of anything, then move on. But it's important to stop and think about it for a minute before you move on. All right, beautiful. Let's see, tab new source int_array.cpp. Oh wow, look at that. I even stubbed out some of the functions for you. Man, I'm the nicest professor ever. Okay. All right. So, int array, array size. So, what are we doing here? What are we doing here?
Reading it to the copy. That's a constructor.
Maybe we should copy the instructions. Copy array's contents into the eternal array. And the other comment here that was on the slide but not here is do a deep copy. All right. So if we need to copy the contents into an internal copy of the array, what's the first thing we need to do?
Make another array.
Make another array. What command are we going to use to do that?
We have to use the new.
We have to use the new. All right. So new what? New what?
New int.
Int. How many?
Size.
Oh man, we're doing great. All right. We probably should store that somewhere. Where do you think we should store it? Array. Beautiful.
You need the star?
No, we don't need a star because it's already a pointer, and new is going to return the memory location of the array in the heap, and the pointer storing a memory location, so you want to copy that directly into the pointer. Great question. Okay. What do we need to do next? It depends. I like that.
Now we need to copy each element.
We need to copy each element. How are we going to do that?
For recursively.
For loop or recursive. You want to do it recursively or with for loop? Which one do you
Not
want?
yet.
All I'm saying is recursively is
That's up to
a lot better. That's like the one thing I remember.
We're going to use a for loop.
Okay.
For int I, where's I starting? 0. I is going to size. We're doing it by 1. All right, so what do we put in here?
In array
Beautiful. All right. Anything we're missing?
Well,
So this is a constructor. When you're in a constructor, always, always, always make sure you initialize every single variable, every single private variable you have. Let's go back and check our private variable list. What are the two variables we have in here?
size.
Array and size. Have we initialized each of them? Which one are we missing? Size. What does that one need to be? Size. Yep. All right, guys. Very good programming practice. Use size here. Can anyone guess? Technically, either one is correct in this case. Why is it a better programming practice to put size right there?
Because M size cannot be changed.
Size can be changed. The reason for it is size might have been changed. Size is a temporary explanation. Size, what if you start copying and pasting this code everywhere, right? Or you start moving it around. You want to make sure you're always referencing what you mean size to be. So here, it's better practice to use size. Obviously, in this location, for this piece of code, either would have sufficed, and that would have been okay. But as a programming practice to guard against future errors, it's best to use the internal variable that you use to store it. Additionally, another programming practice here is to initialize things up top and then start using them as well. Both of those are just good programming practice, although they were not necessary in this case.
Should you flip the first two lines and use size?
Yes. Excellent. Beautiful. That was great. All right. Okay. Let's see. Let's now that we have something, maybe we should do a constructor test. So let's create an int array equals, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So int array, we'll call it IA, passing in array. And how many values are in here?
Was 10.
All right. All right, so we got that done. Make constructor test.
Isn't that out of scope? Yeah.
Scale, oh, whoops. Probably should actually do it correctly. Out of scope. What do you mean out of scope?
Well, it counts from 0, but you put 10. You know what I'm saying? Or
These are the actual elements of the array.
Okay.
Yeah, so I'm storing at sub 0 the value 1, sub 1 the value 2. Confusing you. I'm making you try to remember what each thing represents because C++ has so many corner cases. You got to keep everything straight. All right, so that was done. Let's go and see if we can make it now. All right, what's the error? Error scalar array requires one element in initializer. What? Oh. This is C++ being a little wonky. I think it really wants that, if I recall correctly. Yep, that's what I wanted. Thank you, C++. To do the... Hold on.
Oh, okay.
Yeah, to do the initialization, it wanted the scalar brackets. For the time being, let's just assume that the star and the scalar brackets mean the same thing. For the time being. Hopefully, we'll never get into a situation where I have to explain the difference, because it's pretty minute. All right, so it actually instructs it. That's great. Beautiful. How are we going to test it, though? Well, we probably need to have a get function, don't we? Notice that I did not require you to have a get function, but you are free to add a function to help you with debugging your class code. Please always feel free to do this. So I may go down here and do something like int get int index. I'll just put testing function.
So is that what you want us to do if we did add something?
Yeah. Oh, thank you. I just went into autopilot.
It's okay.
So you declare the function in the class, and then you copy and paste it over to the CPP. Notice you put the class name in front of it, : : that's a scoping operator to declare that this is the function. All right, so what does this need to do? Well, we just want to get it at the index, so we're using this as a testing. So we're just going to return m array sub index, and hopefully index is legit. Okay.
So we're getting the element.
Getting the actual element at that location and returning it. Okay, so the point of this is, let's say, whoops, we're over here. We want to do ts assert equals, we'll do ia.get of, we'll do 0, should be 1, right? All right, let's see if that works. Okay, we're good. So we actually have an idea that this might be correct. Let's go and add a couple more. Let's do a 5, should be 6.
So the IA thing,
That's just my variable. I called it IA.
what do you need to define that?
Actually, you know what, let's do this correctly. DUT, device under test. Another practice, DUT, device under test. It's called device for various reasons, but you can think of it as class under test, but then it's the cut. Oh well. The DUT. If you say cut, you might be thinking you're cutting something, but DUT, no, that has to be an acronym. Well, it's all caps, so it has to be. All right. Just to show you, this is a bad test, because if you get 5, it shouldn't be 4, right? But I want to show you that the C++ test gen will tell you, success rate, it's 0. We tried to do a get of 5 equals 0, and that was the problem. It even tells you the line number 13. So it expected to get 4, but it found 6. So if we look at it, we can go to line 13, and we got back 6, but we were expecting 4. Okay, this actually means that this test case was wrong, so we delete it real quick. Okay? Okay, let's see, let's jump back over here. Oh, get length. Let's do that. Return, or actually, how do we return the length? What do we do?
Return M size.
Oh, right. And that was easy. All right. Let me copy this and let's go and open up test. Let's do length test. Oh, something's already in there. Look at that. That was nice of me. Make.
So we do create a different test for each function.
I highly recommend doing it that way. You don't have to, but I highly recommend it. That way you can test each individual piece one by one until you get it all together. Okay? And right now I've stubbed it out for you so you can see it. But I made that test and said it was fine. It was okay. All right. So that one might be working. All right. Now how do you test the main, blah, 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 blah. Valgrind with main. Let me jump back and do it this way. Well, let's go ahead and create an array. Set equal to 1, 2, 3, 4, 5, 6. So you got to do a manual test. There's really no way around it. So we can call it int array dut array, and this has 6 elements. So it just creates it and then going to destroy it afterwards, right? Let's see if we have any memory problems. So we can do make was not declared in the scope. That means we didn't include it. So let's include it. Okay. Now we can make run. Looks like it was good. So make Valgrind.
So.
Uh-oh.
When it, I lost.
What was your question,
When
Malik?
it comes to running a Valgrind on, let's say, okay, if you want to test the memory leaks, you have to use main. You cannot use.
You can use the CSX test gen. The issue is it'll be harder for Valgrind to decipher between the testing framework and your program. So you're free to do it, and you can do it. I can do, for example, if I did an LS right here, I can do a Valgrind on the test runner. Oh, that time it was able to find everything just fine. So now it ran my tests and then did Valgrind on the test to make sure I freed everything. So, and it was fine here. Notice there's some more Alex, which is fine because it's a testing suite. And in general, this is actually good. You can do it on your test runner. Just Valgrind the test runner, and it'll run Valgrind on the last test you ran. Okay? But in both cases, we lost memory. Definitely lost. What happened?
You didn't delete.
Oh, we didn't delete. Okay. Where does that go?
Emery.
Destructor? Look, it's already stubbed out. What do we need to do? Delete an array, just like that.
So this size, what's M size of?
Not quite. Let me do that. M size. Do we need to delete M size?
No.
Why not?
It's just a regular variable.
It's just a regular variable of the class. It's not pointing to anything. You only need to delete memory that's on the heap. And here, M array is definitely on the heap. Size may or may not be on the heap, but that's not your problem.
Yet.
Yet. Why am I saying it may or may not be on the heap? Well, anyways, let's go and run this real quick. Let's make Valgrind is what I meant to do first. All right, freed it all up. All right, what do I mean by may or may not be on the heap? Is this device under test on the stack or on the heap?
It's on the stack.
It's on the stack. All right. Well, what if I did this?
You just made it a random.
On the heap. What does that mean I need to do? Delete.
Well, I mean, why would you? I mean, if that's just testing, why would you want to do that?
Great question. In general, you don't. But you may be in a situation where you have to. Yeah, try and do it all on the stack. Life will be easier. In general.
Program this whole class on this thing.
Impossible.
Nothing's impossible.
So now if we make Valgrind it, Good. Notice it had more allocations this time because it had to allocate that class on the heap, and then you deleted the class, which deleted the size at that point. Any questions? This is great.